You know, the electricity flowing through the walls of your home is this incredible invisible force. We plug things in and use it every single day without even thinking about it. But how do we actually manage something so powerful and do it safely? Well, let's dive in. Just think about your phone charger for a second. Inside that little plug, there's a serious electrical current flowing, but you can pick it up, you can hold it, no danger at all. So how does that work? The whole secret comes down to a partnership between two very, very different kinds of materials. And these two key players are called conductors and insulators. Now, they have completely opposite jobs, but when they work together, they let us control electricity with just amazing precision and, most importantly, safety. So first up, we've got the conductor. The easiest way to think about it is like a super wide open highway for electricity. It's a material that just lets that current flow right on through, getting it exactly where we need it to go with no fuss. And then you have its total opposite, the insulator. This material does everything it possibly can to stop the flow of electricity. So if a conductor is that open highway, an insulator is a solid brick wall. It's a roadblock that keeps that current completely contained. So let's just break that down side by side. Conductors, things like copper, silver, aluminum, they have really low resistance. That just means the current can flow through them super easily. Insulators, on the other hand, we're talking plastic, rubber, glass. They have super high resistance, which basically blocks that current cold. They are the yin and yang of electricity. Okay, but what makes them so different? I mean, why does one let electricity through and the other one stops it? To really get it, we have to zoom in, like way, way in, all the way down to the level of atoms. That's where the real magic is happening. So what is actually going on inside these materials? What makes a piece of metal so fundamentally different from a piece of plastic? The secret isn't just what they're made of, but it's how their tiniest little particles are put together. And that brings us to the real hero of our story, the free electron. You see, every atom has these little particles called electrons orbiting it. But in some materials, a few of those electrons are kind of rebellious. They're not held on very tightly. They're basically free to jump from one atom to the next, and they carry an electrical charge with them as they go. And this is the aha moment. Metals are just packed with these free electrons. So many, in fact, that scientists call it a sea of electrons that can just flow wherever they want. And that flow? That's what we call an electric current. But in insulators like plastic, the electrons are locked down tight to their atoms. They can't go anywhere, so no current can flow. Simple as that. Here's a way to picture it. Imagine the atoms in a metal are arranged in this really neat, organized grid, right? A crystal lattice. But weaving all through that grid, like a river, is this massive, mobile sea of free electrons. They're just hanging out, waiting for a little push to get moving and create a current. All right, so you're probably thinking, got it. Metals conduct, plastics insulate. But this story isn't just about wires and plastic. These properties of conducting and insulating, they show up in some really surprising places. Get this, the graphite in the pencil you write with, it's not even a metal, but it's a great conductor. And water? You'd think it all conducts electricity, right? Wrong. Pure distilled water is actually an insulator. It's the regular old tap water with all the minerals dissolved in it that can conduct electricity. And believe it or not, the very air around us is an insulator. Most of the time anyway. Because under the right, really extreme conditions, that can all change in a flash. A bolt of lightning is the perfect example. It is a massive electrical current that is literally forcing its way through the air, turning that powerful insulator into a conductor for just a split second. Okay, so let's circle all the way back to our original puzzle, the plug. Now that we've met the two key players, the conductor and the insulator, we can finally see how they work together to get us power safely. It really is a perfect partnership. On the inside of the cable, you've got a copper wire. That's our conductor. It's the highway for that sea of electrons to flow down. And then, wrapped around the outside, you have a plastic sheath. That's our insulator. It's the roadblock, making absolutely sure the current stays right where it's supposed to be. And that is the reason why you can hold a plug or touch the outside of a wire without giving it a second thought. That insulator creates a protective barrier, safely containing all of that electrical energy that's flowing just millimeters away from your hand. It's so simple, but it's absolutely brilliant. So, when you step back and think about it, this simple pairing is the foundation of our entire modern world. I mean, from the lights in your ceiling to the phone in your pocket, this elegant control of how electrons flow is what makes it all work. Our whole society is basically built on this one trick: mastering how to guide the flow of electrons through conductors and how to stop them with insulators. It kind of makes you wonder, doesn't it? Now that we've conquered this fundamental force of nature, what are we going to master next?